All right. So last unit we focused on when I see you guys on Tuesday, we're gonna go over the test and give you guys. I'll release all the answers probably by Monday morning, so you guys can see your grades and you can see how well you did. I am not going to do a test corrections this time for points back. So if you want to test for a higher grade, you'll have to actually do a retest. We focus on collecting data through surveys, collecting basic with experiments, talking about biases. Now we're going to talk about analyzing data, analyzing statistics. And so we're going to start out with the basics. First and foremost, let's go back to fifth grade. Actually, and before we do that, answer this question. Answer this open-ended question. What do you think the word quantitative means? There's no right or wrong answer. If you want to Google it, you can. Some people did that earlier, but don't worry about that. What do you think quantitative means? Just answer the question, and we'll look at some answers that you guys come up with. Make sure you, on each of these screens that you press submit, so it records your answer. That's how it shows me. There's a on the back end of this, it tells me that did you participate, just participation wise. If it's 100%, I'm not even going to look at your answers, guys. Don't put in like BS stuff though. I'm gonna start to see. But write out what you think. What do you think the word quantitative means? A large sum. The amount. Yep. Measurement. About like 10 more seconds, guys. Make sure you press submit. Most of you are on the right track. Miranda said dealing with measuring. Yeah, it's got to be something that's measurable. Okay, quantitative. How many you guys in class can see this? Let's look at the stack of pink papers that I have right here. How many of you are good at estimating? How many papers do you think are in that stack? Actually, I'm gonna let people at home take a look at this too. Okay, put in the chat. What is your estimate of the number of papers in this stack? 250. About 250.
How many students do you have?
This is not for. This is something random. 1,000. 800.
Yeah, I'm good.
Okay, so 1,000 is definitely the highest that I've got today, but the lowest I got was 40. Okay, this is way more than 40 pieces of paper. I want you to explain, Ethan, what you think your where you got 250 from.
How much is there, like how small it is,
and
then compared to how thick it is right there,
and
knowing that you probably won't have a lot of people.
Okay.
So maybe
I was thinking that your train of thought was going to be somewhere else. You guys know how many sheets are in a ream of paper? 500. Yeah, in a whole ream. Right. That's about half the ream. So it's about 200 to 250. Yeah.
I was gonna say.
Yeah, because
Less than a ream.
a ream of paper is like this thick right here. So that's a good estimate. Obviously, we could figure out, if I ask somebody right now to count it, you can count it. Quantitative data has to be something that's countable, measurable. A lot of you guys use those words. Okay. Different than qualitative data. Qualitative data is something that we combine together categories. What's your favorite color? That's qualitative. Okay. What grade are you in? But depending on the way you number that, it could be 1 through 12, which is quantitative, or it could be freshman, sophomore, junior, senior, and that could be qualitative, right? But quantitative has to be a number answer. It has to be a number answer. Make sure that you're aware of that, because when you guys do surveys later on in this semester or in this unit, you guys will have to have a question that's quantitative on your survey. All right. Now let's go back to fifth grade. All right. Measures of center. There's 3 measures of center that you guys probably learned in 5th or 6th grade, and they all start with M's. First one, mean. What does the mean? Average. Okay. Average. How do I find the average of a set of numbers? Add them all up and divide by how many there are. Okay, super easy. What's the median?
Adding all, wait, no.
The median is like the number. It's the middle number from the highest. It's the one between the highest and lowest.
Okay, so it's the middle number in a set of numbers, as long as the numbers are in order from least to greatest. Okay, you guys knew that. It's been a while, but you knew that. All right. And who remembers what the last M is? Mean, median, and it's a 4-letter word.
The range also.
We'll get to that later. We're not going to do that today.
Median and
Mode. The one that shows up the most. Okay, the one that shows up the most. Right now, the mode for the test will probably be a 0. The one that shows up the most. People that didn't take the test yet, or just didn't take it, and they're not going to take it. All right. Let's practice with that. I'm not going to go too deep into this because I think you guys know how to do these things. All right. So let's practice. First, student has the following grades in class where everything is weighted equally. Look at those grades there. Count up how many there are, and you're not writing this on the screen or anything. Just follow along. Somebody tell me. Just yell it out or type it in the chat. What is the median grade? You should be able to tell pretty quick and pretty easily. I'm gonna how do I let's see? How do I annotate on here as the all right? You guys are right, obviously. The median is 75. It's the middle number there on the screen. Okay. There's 3 numbers in the front side, 3 numbers on the back side. 75 is the exact middle number. Super easy. Grab your cell phone calculator and see if you can figure out what the mean is. Grab your cell phone calculator, or you can grab a calculator in the back if you want to. Tell me what the mean is. There we go. What is the mean? What are you going to do with those 7 numbers? You're going to add them all up and divide by 7. But you will want to round. If you're talking about grades, you round to the nearest whole number. So just round to the nearest whole number.
$78.
78. 78. Yep. Good job. Add them all up, divide by 7. Now, you guys using your cell phone calculators, don't make these rookie mistakes, okay? A rookie will add up all the numbers, and instead of pressing enter before they hit divide by 7, they'll add them all up, divide by 7, and hit enter. Don't do that. Okay, add them up, hit enter, and then press divide by 7. Order of operations will make it that you can't I'm sorry, you'll be out of the loop there. Okay. All right, let's see how it happens. This is exactly what happened to some of you guys with your test or missing assignment. Okay, suppose that a student did not turn in their final assignment this semester and received a 0. This is what their grades look like now. Tell me, what is now the median grade? What is now the median grade? How do we figure that out? Is there a middle number anymore? No, there's 2 middle numbers now. These 2 are now in the middle. So how do I figure out which is the median? Find the average of the 2 that are in the middle. You probably don't need a calculator for that. If you add both of those up and divide by 2, you get 74.5. Okay, that's an easy one. Did the median get changed very much? No, before it was 75, now it's just 74.5. Barely changed. Barely changed just because of that killer zero. What do you think is going to happen to the average, the mean? Find the mean now. Okay. Find the mean and see what happens to it. Find the mean with the zero in there. What happens to your average? Before the average was a 78. Not too bad, not too shabby. But some of you wish you had a 78.
68.
68?
No, 69.
69. Okay. So not only did that 1-0 bring down your average 9 points, but you're no longer passing. And you're no longer passing. What, like I said, what's the median barely got affected, but the average, the mean got affected quite a bit, right? That 1-0, just that 1-0. And I hear this all the time, like, God, I got another 100 on an assignment. I didn't do anything in my grade. Yeah, because you got like all 90s and 100s on your assignments. Of course, it's not going to change that much. But when you get a 0, you're like, oh my God, I dropped my grade 10 points. How many of you ever thought that? When you don't turn in an assignment? Faith, you?
Oh, yeah.
Yeah. Okay. All right. I forgot what I had on this next slide. I think it's like a little game. It's kind of like a Kahoot within the Nearpod. Let's see if you can answer these two questions based on what we just saw, because these data, and I want to explain to you guys. This mean? Oh, I guess you got to pick a character. What? I'll pick this guy. You guys playing? Student number 001. Who's that? You guys got to put your names on here, or else I'm not going to know who's to give you guys credit. What?
Actually,
Yeah, he looks like it now. That's funny. I'm just built different.
All right. Let's see what. Answer these two questions. There's just two questions on here. Which measure center was affected more by the 0? The median or the mean? Which one was affected more by the 0? The median or the mean? I'm gonna put. All right, next question. It was the mean was affected more. Which measure center do you think is resistant to outliers? Even if you're not sure what that word outliers is. That 0 was an outlier. Which one do you think is resistant to outliers? The median or the mean? So who won that? Ethan was the fastest. Good job, Ethan.
Oh, it's a race?
Yeah, it was like a Kahoot type, but only Jojo fishing and Lizzie coming in third. So outliers, just real quickly. Outliers are numbers that are extreme from the data. Okay. There's a reason why when you look at statistics like on the city of Austin, you look at average income levels, they will never tell you the mean. They will never tell you the average of the income levels of people in Austin. They will always show you the median, because the median is a more true representation of the income levels of people in Austin. Why? Why do you think that the averages would be skewed if we use the average for income level of people in Austin?
There's a lot of homes.
Okay, so don't think on that end of it. Yeah, you're saying there's homeless people that don't make any money. Well, think about the other end of the spectrum, not the zeros, like the grade average, but the Westlake side of Austin or the Lake Travis side of Austin. Do you think that residents in Westlake and Lake Travis represent the majority of residents in Austin? No, not necessarily. Those people are making millions of dollars. You know, not every one of them, but a lot of those. You got the millionaires in Austin who bring up the average quite a bit. And when somebody like me who's only making $60,000 a year, is probably a little bit more representative of most of the people that live in the Austin area. So when you guys take a test, I don't think does the student portal still show you guys the average of the test grades in your student portal? Can you see what the average is? You used to be able to. I don't think you can anymore. What? Yeah, it used to show you the test average because I used to have parents ask me about that, and I had to explain to parents like when a parent would tell me like, well, the average is a 50 something, you know, you're not doing something right. Well, it's not necessarily that I'm not doing something right. It's the fact that I have 3 students that didn't take the test and got a 0, right? And so now if I took those zeros out, the average is actually above a 70. But those 3 zeros absolutely killed my average. So what's a better representation? Maybe I show them what the median is. The median would not really, the zeros won't really affect the average, the true representation of the scores rather than the average does. So median a lot of times can be a lot better measure of what representation is centered. All right. So let's talk about some different graphs. I'm going to roll through these pretty quickly because they're ones that you guys did in 6th grade. Let's see if you remember, Faith. You know what a dot plot is?
Dot plot.
Have you made a dot plot? All right, you remember dot plots? I know y'all had to have done them at some point. I'm not gonna make you make dot plots because they're super easy. You guys done them in 6th grade, but let's talk about them. Here's a dot plot for the gold medal winning countries, top 20 gold medal winning countries, or medal winning countries in general, and how many gold medals they won in the 2010 Winter Olympics. Are we having Olympics this year finally? All right, Summer Olympics in Japan, I think.
I don't think
it's scheduled.
Oh, well, COVID, so I don't know.
It's scheduled
We're playing sports, so.
way later.
All right, let's see if you guys answer this question, these 2 quiz questions, and blow up the this here. Answer the questions on your screen. There's 2 quiz questions. Make sure you answer both of them and press submit. Look at the dot plot, see if you can understand it, and answer those 2 questions. See if you can answer those 2 questions. Up there on the screen. Are you able to blow up the picture on your own screen too? No? Yeah, you can?
Mm-hmm.
Okay. Does it tell you if you got it right or wrong? Not yet. All right, guys, about 15 more seconds, and I'm going to share the correct answers up for you guys. Question number 1 said, how many countries? Ooh, got 4 wrong answers here. All right, let's go over this. How many countries in the top 20 won 2 gold medals? Now look over here at 2. How many countries were there? 1, 2, 3 countries. 3 countries. 1. That's how you read it.
Yeah, okay.
Okay. I know. This is why we're reviewing it. And I mean, once you get it, you get it. We're not gonna spend a week on this. 3 countries won 2 gold medals. That should have been the first one. Let me see. Let's share the results for everybody. Dang. Yeah. Let's go back and go over the next question then. Next question was, what is the mode of the data set? Mode is the one that shows up the most. The one that shows up the most is number one. So 1 is the mode. Then some of you got that, some of you didn't. All right, now you get it, right? All right, okay, we can move on. Are you able to find the median in a dot plot? Aren't they already listed in order from least to greatest? There's 2 zeros, there's 4 ones, there's 3 twos. Could I not very hard find the median?
Yeah, I guess you just put like pieces of it in and.
They're already in order. I don't really need to do that. How about if I do something like this? Take off 1 here. I'm gonna change this color. Red. So I take off 1 here. Take off 1 here. So there's a top 1 here, 1 here, 1 there. What am I doing here? I'm eliminating 1 from each side so I can try to find what? The middle, yeah. I'm literally just trying to find the middle number by eliminating 1 from each side until I get into the middle. So what does my median have to be here? 3.5. Okay, it has to be 3.5. Has to be there. It's pretty easy to find the median there, but you can do it. Cool. All right, the other one we're going to talk about today is stem plots. Stem plots. Have you done a stem plot before? You should have done this in about 6th grade. Who was your 6th grade math teacher? Do you remember?
6th grade math teacher?
Yeah. Where'd you go to school?
In Brownsville.
Oh.
Yeah.
Any of y'all go to Wallace? No? Chapa?
Chopper.
It's not like some sick coach.
Yeah.
Coach Cox.
Oh, I had Coach Cox too for like 2 months.
2 months.
Yeah, 2 months.
Was that? That was 6th grade, yeah.
Yeah. And
What?
Coach Cox, I don't remember him.
You just said you went to a different high school.
I did until April. I moved here in April.
Oh, that's right. You came later than me.
Yeah.
Who'd you guys have? Where'd y'all go to middle school? You guys at home that I never see? Lizzie, you went to Simon, I know that, right?
I'm surprised that you remember that. Got a freaking brain, dude. I remember stuff. It's crazy.
Okay. I bet you guys if I showed you, Nyla, you were in Austin? What middle school did you go to? I bet you guys if I showed you a stem plot, you would remember how to do it. Okay. Stem plot where you have the stem on this left side, that's the tens digit or the hundreds digit. It's the first digits in the number. And then this is the number that's afterwards. So you've never seen a stem plot? So for example, the lowest number on this stem plot is a 68. A 68 is the lowest number. Okay. The highest number is 110. 1, 1, and then 0. Okay. If I wanted to find the median on this, I could do the same thing. I could just cross off the lowest number, highest number, and I would keep going until I find the middle. Okay. So it's definitely possible to find the middle that way. I'm not going to keep going, but that's how you read a stem plot. All right. Oh, really? That's cool, Nyla. Okay. When you have only a few stems, data can appear bunched up. So you can split the data if you want. I'm not going to go over this. I just wanted to show you can split data on a stem plot. Notice how there are now from 1 6, there's 2 6s, there's 2 7s, 2 8s, and 2 9s. So you do the first half of the numbers on one row, the second half on the next row, if you were to make a stem plot. Okay. What I want to show you, what you might see more now in an advanced class, is a back-to-back stem plot. But be careful when you read these, because even though a regular stem plot is really easy to read, it's sometimes can get difficult on a back-to-back stem plot because you might get confused with the way that it's written. So look at this one about potato chips versus tortilla chips. The stem is still in the middle. Okay, the stem is still in the middle. Watch this. What's the lowest number on this? What is the lowest number on this chart? Anybody?
Zero.
Not 0.
Oh. Or
What is this number? This is 110. How many 110s are there?
Oh, oh,
Not 12. There's
two?
this is 100. Look at this. Look at this key right here. 1 5 with a line and a 0 means 150. Okay, so the stem. This means this is 110, and there's two 110. So there's two bags that have 110 calories. What is this number right here? What's the very next number? What's this number right here? What'd you say?
1,200?
Not 1200.
No, no.
120. Okay. The only difference is it's going to the left now for the one that it's comparing against, because we're comparing two things. What is this number?
135.
135. That one's easy to read. Okay. What about this number? What's 130? What's the other 130 that they have there? This number right here is what? $135. Okay, you guys see how to read this? All right, you know how to read this now? Answer this next question. Answer that next question. Blow it up if you need to. Answer that question on your screen. The bag of chips that has the highest number has how many calories? There it is again. Highest number has how many calories? Let's see if you paid attention to what I just said. These aren't hard. This isn't hard. So you know how to read it. Pick an answer, pick an answer, pick an answer. Most of you are getting it right. Almost 100%. Yeah, it is 172. 172. Okay. So last thing with the stem plots, okay, or one of the last things with the stem plots. Take a look at these four classes, because I want to relate this to how I kind of show you guys. Imagine these are four classes that I have, and they all took a test. All four of these classes have an average of 75, have a mean of 75. Good or bad? On the first take, what do you think? Everybody, all classes average passing. Good, right? Yeah. Does that mean that all four of these classes did about the same? They said equally well. Okay. Answer this open response question. And again, there's no right or wrong answer. Okay. You can actually, those of you at home or you guys here, if you allow your microphone, you can actually leave a voice answer if you want to. It'll let you leave a voice answer. All four of these classes had a average score of 75. Does that mean they all did equally well? Write me in one or two sentences. Why or why not? Don't just say yes or no. All four had an average of 75. Does that mean they all did equally well? Look at the numbers in each class. Don't worry about reading right or wrong. Just participate. What do you guys think? How so, Lizzie? Tell me. You said some classes did better than others. Explain. Can you explain that? Can you unmute yourself? So as you guys are writing your answers, what do you notice about this first first period? Pretty good. How many people failed? Just 2 people. Literally only 2 people failed in this first period. One person got a 25, one person got a 40. Everybody else got above a 70. They also had a 100 and a 90. But there's only 2 A's as well. So a bunch of people bunched in the 70s and 80s. So a bunch of B's and a bunch of C's. I would say pretty decent class. I would love a class to look like that. What about this class? What do you notice about this class? A lot more people failed. What? No, because I mean this is the failure rate. I wouldn't say half, but definitely like you had these guys that were in the middle, right on the borderline in the 70s, and you had half above and below that for sure. That one's all right. What about this one? This is way evenly more spread out. 4 A's but no hundreds. Okay. I like this class better than this class because there are a lot more A's and B's, right? What about this class? I don't like this class. Why do you think I not like this class? A lot of people failed. There's a lot of people right here borderline, but even though that there are 4 A's, high A's, those 4 A's brought the average up. But there's a lot of people that failed this class more so than any other class. So even though they all have a 75 average, it doesn't mean that they're all equally the same. Yeah, there's some of them that are really close, getting people passing. But remember, those averages can be deceiving, can be really deceiving until we actually look at the data. Okay, looking at the data, and I bet you the medians on all these would be a lot different. Okay. All right, so dots plots, stem plots, all that stuff's there. Dot plots, stem plots, we use them for small data sets. If I wanted to make a dot plot or stem plot for 6th period, pretty easy. I can make it really fast. There's only 28, 30. There's how many of you now? 29. Okay, there's 29 of you guys. Pretty easy to make a dot plot or stem plot. What if I wanted to make a dot plot or stem plot for all 5 of my classes? That's like 160 students. Faith, you want to make a dot plot for me for 160 students?
No.
Why not?
160 students is a lot of dots.
That's a lot of dots, right? So we don't use dot plots and stem plots for large data sets. Next week, I'll show you guys 2 different things that we do besides dot plots and stem plots. These are really only useful for small data sets, but they are really good at trying to get you to show this last section. So here's the last part. We'll be done. Is describing a distribution. Guys, I know you don't like writing, but we're going to write more in this unit. But we're going to write small sentences. I know you here don't. We got to write. Writing is a key component of life. Okay? Got to know how to write well. So I'm going to get you guys to describe distributions, and these are 4 things that we're going to focus on. Look at this acronym that I have here. In order to analyze data and describe it, you're going to use the cuss method. You're not going to cuss at me. You're not going to cuss at your friends or cuss on your paper. Okay, but you're going to use the cuss method because that is the acronym that we're going to use. The C stands for center. The U stands for unusual features. The first S stands for shape, and the second S stands for spread. Okay. Are you wanting to cuss or what?
No, it just said like if you replace the C with an S.
Sus? What does that mean? Like suspect? Why do y'all use that?
No,
Suspicious? Y'all, why do y'all have to shorten a word? It's already short.
Suspicious is a long and
Suspicious
hard to
is
say
not
word.
a short word.
That's
You guys are
how do you
crazy.
spell it? Are you kidding me? I'm not gonna text suspicious.
All right. So when you describe, I'm gonna show you some examples. When you describe the center of a distribution, you're gonna use the 3 M's that we talked about earlier: mean, median, and mode. Okay. You can find mean, median, and mode on most distributions pretty easily, and I'll show you how. Okay. Two types of unusual features there might be in a chart or graph. One is called a gap. Okay, if there's a gap in the data, you can see gaps down here. Okay, you can see you can see gaps down here in the data. That's an unusual feature. Okay, not all distributions have gaps. The other one is called a outlier. Have you heard the term outlier before, besides today? Okay, outliers, extreme data sets, extreme data points, those zeros. Or if everybody failed and Draven got 100, again, then maybe he's the outlier. When was the last time you didn't get 100 on a test?
This last test.
How do you know?
I know for a fact. Can I get
So-
100 without answering all the questions?
You didn't answer all the questions?
It's a-
So gaps and outliers are unusual features. So center, unusual features, and then the shape. Watch these. I'm gonna, guys, pull it up on your phone or on the screen here. And Faith, tell your friend, text him back in a few minutes. All right. Describe the overall pattern of the distribution. There's different shapes. I'm going to show you what these shapes look like. So you got to start looking at these and so you can memorize them. All right, ready? The first is a symmetrical shape. We all know what symmetry looks like. We did this in geometry. But in geometry, in order for something to be symmetrical, you had to do what with it? Cut it down in half. If it folds over in that imaginary line and it matched up perfectly, it was symmetrical. What if it didn't match up perfectly? It was asymmetrical, not symmetrical. Okay. In statistics, that's not the case. It doesn't have to be a perfect symmetry in order for it to be symmetrical. This graph right here, not perfect symmetry, but it's mostly symmetrical. And that's when we'll use adjectives. Mostly symmetrical graph. Okay. This is also called bimodal because there's two peaks, and bi means two. Okay. If it's one peak, what do you think it's called? If bi is two, what's one? Unimodal. Perfect. Good. If if you have a graph where all the data is about the same height, it's called uniform. Okay, called uniform. Data all the same height, it's called uniform. But if you have data that leans one way or the other, this data looks like it's leaning which direction? It looks like it's leaning to the right, right? But it's actually called skewed left or left skewed. Okay. It's always skewed in the direction of whatever the tail is. And this one has a tail down over here on the left side. So just think of the tail, that's the skew. All right. This one is also called unimodal because it has one peak. All right. I'll show you what it looks like. Here's a symmetric unimodal. Okay, mostly symmetric. It's not perfectly symmetrical, mostly symmetric. And then here's a right skewed graph, tails on the right. Okay, it looks like it's leaning to the left, but the tail's on the right. Cool? All right, almost done here. The last S is spread. We're going to talk about that later, so we're not going to talk about it today. We're only going to talk about three things: center, unusual features, and shape. So take a look at this. Help me out here. Y'all pull this up on your phone. Look at the very middle. You have a symmetrical graph right here in the middle. This one's actually perfectly symmetrical. You can cut it in half. In a perfectly symmetrical distribution of data, the mean, the median, and the mode are all exactly the same. And they're all right in the middle. They have to be. The mode has got to be the highest point, right? The most data that shows up. The median is always in the middle. And if it's symmetrical, that's in the middle. And then the mean will also be the same, exactly the same, if it's perfectly symmetrical. But if it's skewed to the left or skewed to the right, those measures of center, those mean, median, and mode, they change a little bit. Label. I want you guys to label what you think is going to happen to these mean, median, and mode. And I'll get you started out here. Which one has to be the top one on each one of these? The JoJo. What did you say? Which measure of center, mean, median, or mode is the one that shows up the most? The mode is the one that shows up the most. Isn't our highest point going to be this number, whatever shows up the most? So these top points still have to be the mode. Okay, so label those the mode on your screen. You can use, I think you can type it in or you can draw it in. Okay, those are the mode. Now, when you're trying,
Click that. What's the code?
F5JI9. Those two have to be the mode. Now, when I have you guys label this from earlier, think about what we did earlier with that killer 0 assignment grade. What got affected the most with that 0? Imagine this zero over here. Look up on the screen. Imagine the 0 being over here. Which got affected more by the 0, the mean or the median? The mean got affected more, right? Your average dropped way more than the median did. So which one does this line have to be, the mean or the median? The mean, it has to be. Okay, the mean gets affected quite a bit by outliers. We already proved that earlier. The median gets affected a little, but not a lot. Okay, so this is the median. Same thing on the other side. If you have a high outlier, those Westlake residents, okay, they're going to bring up the average. They're going to bring up the mean of the income level in the city of Austin. But they're not going to affect the median that much. And I bet you if you go to Austin's Wikipedia page, it's going to tell you the median income level for Austin. It won't tell you the mean. There's no point in looking at the mean. It really isn't on a data set like that. Okay. Make sure you press submit so it saves your stuff. Good. Can I move on? Some of y'all like writing really big. That's funny. You should be able to review these later as notes. Okay. All right. This is the last part. I want to talk to you guys about how I want you to describe distributions. Okay. See that phrase that I wrote, describe the distribution? This dot plot shows a display of the number of passengers observed in 32 cars stopped at a traffic light. When I describe the distribution, this is what we're going to talk about. The center, any unusual features, and the shape. We're not going to do spread right now because we'll do that later. Okay. Center, unusual features, and shape. Which center could I find easiest on this graph? Mean, median, or mode? Okay, what's the mode? 0. Okay, so the center is at 0, which is the mode. That would be your first sentence. That's an easy one to find. Okay, I actually found the median on this one, which was 1, but I use that one instead. You could use either one, as long as you're describing one or the other. Okay, there's your first sentence. You're about to do this in a minute on your own, so y'all just pay attention to these examples. Are there any unusual features in this graph? Are there any gaps or any outliers?
There's a gap at 5.
There's a gap at 5. Okay, there's two ways you can say it. There's a gap at 5, or there's a gap between 4 and 6. Okay. I wrote the unusual feature is that there is a gap between 4 and 6. Good. What's the shape? Last one.
It's right.
Right skewed, right? Skewed to the right or right skewed. Doesn't matter which way you say that. The graph is skewed. The shape of the graph is skewed to the right. I also put unimodal because it has one peak. It has that one peak there at 0. So when I say I want you to write in complete sentences, look how short these sentences are, and you described all 3 things that I need you to describe for the distribution. Pretty easy, okay? I'm going to show you 2 more examples, and you're going to do one on your own. Anybody been to Yellowstone? Seen Old Faithful? You know what Old Faithful is? You don't know what Old Faithful is? The little geyser that shoots up, like every hour. Here's a chart that shows the interval and the frequency of the geyser shooting up over 23 days. So tell me, where do you think the center is on this graph? Just throw out a number. Yeah,
No, 75.
about 75. How do we know that this center is about in the middle? Not just because it's bimodal, because it's mostly symmetrical. So we know that the center has to be in the middle, right? So I wrote center of the graph's around 75, about the median. Okay, the median has to be in the middle if it's symmetrical, which is also the mean as well. Is there any unusual features in this graph? Any gaps? No. Any outliers? Not that you can tell. So, if there are no unusual features, say that. There are no unusual features. All right? Short sentence. What's the shape, Faith?
Shape is, the one peak.
That's one peak?
Well, I mean, there's multiple, like, there's only one high one.
But there's still 2 peaks.
It's symmetrical.
Okay, it's symmetrical. Is it perfectly symmetrical?
No,
Okay, let's use an adjective then.
mostly.
It's mostly symmetrical. And
And,
2 peaks. How do you say it? Bimodal. Yeah. Okay. Not Twin Peaks, not the restaurant. All right. The shape of the graph is mostly symmetrical and bimodal. There you go. Look at that. It's not even a whole paragraph. You got 3 sentences and it's not even a whole paragraph.
Yellowstone is in Wyoming?
Wyoming, yeah.
Really?
Yeah, well, parts of Wyoming and Montana. Yeah. It's over both states and maybe even parts of Idaho too. I can't remember. All right. Look. I've been to Utah. It's not Yellowstone doesn't cover Utah though. Utah is kind of a weird state. Salt Lake City is just different, way different. Here's two sections of a college algebra class, a day class and an evening class, and there's final exam scores. If it asks you to compare 2 distributions, compare them. Give me the center for both of them. Give me the shape for both of them. Give me the unusual features for both of them. Okay, I'm gonna go through this kind of quick so we can wrap up. The center for the day students I found was 71, and the center for the evening students we found was 60. I showed you how to find those earlier. You guys can figure that out on your own. If you really wanted to find the average, you could find the average. You add it all up and divide by how many there are. Is there any unusual features for the day students? There's a gap at what? Between 32 and 58. Okay. You could say that there's a gap, but don't say at 4. There's a gap in the 40s. Like nobody got a 40. All right. Remember, it's not 4, it's 40 for that one. There's no unusual features for the evening students, it appears. The last part is what I wanted to talk to you guys about because this is where you guys will get confused. The evening students' shape. Okay. Ethan, what do you think the shape of the evening students is? That one's an easy one to see. Symmetrical, right? It's almost perfectly symmetrical for the evening students. That one's easy. But the day students, that's the one where I want you guys to look at. Think about this. If you're going to tilt your head, which way are you going to tilt your head? Tilt it to the... Why to the left? So we know it. The day students are skewed for sure, right?
Yeah.
Which direction is it skewed?
It's skewed to the right.
Because it's going from lowest to greatest.
It's got to be skewed to the left because the low numbers are up here and the high numbers are up here, down here. So the low numbers has the tail on this side. You're going to look at it this direction right here.
Okay, isn't that skewed right, or are we looking at it from?
No, it's skewed.
Oh,
So
because
turn your
it's
head to the
right.
right because the low numbers have to be on this side, remember?
Yeah.
So the tail being on this side means it's skewed to the left. Okay, so that's the one I wanted to point out to you guys. All right, that one's skewed to the left. Evening students are still symmetrical. All right, you got your own here. You got your own here, and I can help you guys out. I want you to write 3 really short sentences on this distribution. 3 really short sentences. I'll help you find the center. And I'll start crossing it out on the screen so you guys can see. So that one and that one are out. I'll take these 2 out and these 2 out. And I can take these 3 and these 3. That means the center has to be right here. What is that? 9. So the center is at 9 and the median is at 9. There's your first sentence. Median is at 9. What's the next thing you should say? Unusual features? Okay. So is there an outlier, you guys think? Yeah, I think 0 is probably an outlier. It's pretty far out there. So there's an outlier at 0. That should be the next thing you should say. And what else?
And there's a gap between 12 and 14.
There's a gap between 12 and 14. Or there's a gap at 13. Whichever one. A gap between 12 and 14. It's good to say between 2 numbers because sometimes the gaps are a little bit bigger.
Oh.
Yeah. So a gap between 12 and 14. All right, last short sentence. What's the shape? It's about almost all the same size. I would say mostly uniform. If you say mostly uniform, you don't have to say symmetrical because by definition, uniform is symmetrical. So I would just say mostly the graph is mostly uniform, period, done. All right. So that's how you guys are going to do these. You'll have more practice for this next week. That's how you do these describing distributions. And you're going to make some of your own. We're not done yet, so don't log out. But I found an iPhone app. I guess it looks exactly like the TI-84 calculators. Does anybody know what I'm talking about?
Yes, I've had it before.
Really? Somebody found one the other day, and it literally looks exactly the same. So I'm gonna start playing around with that on my iPad to see if it works, and then start telling you guys, because then we can do a lot of the things that we would normally do, because almost all of you guys have iPhones, and those of you that have Android, and like all you cool people with Androids have an even better app. All right, everybody answer. Make sure you submit Miranda, Jose. I'm gonna get to your exit ticket. Okay, exit ticket now. Submit it. Jose, you still there? Here's what I want you to do as your exit. Oh, I put the answer up there. Center is at 9. There's a gap between 12 and 14. Outlier is 0. Shape is mostly uniform. You don't really have to say symmetrical. Okay. Here's your exit ticket. It's set up as a collaboration board. So here's what I want you guys to do. I want you guys to pull it up. Does it show up big there? There you go. Pull it up and put 3 different sticky notes. Right, one for the center, one for the unusual features, and one for the shape. That way you guys can start seeing what other people are saying. It doesn't have to be in that order either. Okay, so 3 different sticky notes. One for the center, one for unusual features, and one for the shape. 3 short sentences for each one of those. Once you finish those, you can save it and log out. This is your exit ticket. This is what I'm going to grade on your last one because I'm not going to help you with this one, but you guys can collaborate. So put one at a time. 3 different sticky notes on there. Remember, if you don't think there are any unusual features, then say so. Okay, that's got to be your 3 different sticky notes that I'm looking for. And this is the one I'll be grading you guys on. Once you're done with that, you guys can log out and have a great weekend. And if you need anything, let me know. We'll go over the test on Tuesday. And remember, Tuesday is 2 birds with 1 stone.